Hello and welcome to Elevating Private Cloud Security Against Malware and AI-Driven Attacks. My name is Chris McCain. I'm the Global Field CTO for Application Networking and Security at VMware by Broadcom. Today's session, I want to talk about not just private cloud, but what does it mean to have a secure private cloud? What are the tools? Where are the enforcement points for the tools that are purpose-built to protect a private cloud? How do we introduce these into our brownfield environments to be able to buy down risk and feel comfortable with the security posture that's developed in the private cloud? So what we're starting with here on the screen is our VMware Cloud Foundation-based private cloud. You have your hypervisor in the middle. Underneath there is your software-defined storage with virtual SAN, and then our software-defined networking with NSX. Of course, all of this runs on top of the physical network fabric, and all of this runs under the virtual machines and containers that we have as workloads in the enterprise. Now, of course, as part of this VMware Cloud Foundation private cloud, we have our management tool, which is vCenter Server. We have our operations tools, VCF Ops, and we have our automation tools, VCF Automation. And we could add to the mix NSX Manager as one of our other management tools, our management plane. And that's certainly relevant for our security discussion today. Now, in the picture, I do have a traditional physical firewall there. That physical firewall is not something that we are trying to replace. That physical firewall is still that first barrier of entry into your own private cloud infrastructure. But I think we are way beyond the argument as to whether or not a physical firewall is enough to protect against modern day attacks. I think we will find no disagreement in the idea that we must have a defense in-depth strategy within the organization to be able to protect against the way most malicious threat actors are working today. And that is through lateral movement and through the exploit of vulnerabilities that exist within the environment. So today, we're going to talk about how we can mitigate against these different types of things, and especially in today's environment where AI is accelerating the rate at which these attacks can happen, but also accelerating the rate at which vulnerabilities are discovered. So we have to be able to protect the environment at a velocity that allows us to at least try and keep pace in this cat and mouse game that we have with malicious threat actors. So when we look at security from the perspective of VMware, we have a product called VMware vDefend. Now, if you are familiar with the older NSX products, NSX used to be networking and or security. And after the acquisition of VMware by Broadcom, the networking components from NSX were baked into the VMware Cloud Foundation, as we see in this diagram so far. And the security components out of the artist formerly known as NSX are now branded as VMware vDefend. So what do we get when we leverage VMware vDefend in the environment, or we buy VMware vDefend? Well, we get the distributed firewall, we get gateway firewall, we get bare metal agents, there's distributed IDS IPS, there's malware prevention. We get a management component called SSP, or Security Services Platform, which facilitates the security journey feature. And we'll talk about that today. Also facilitates the network traffic analysis, so provides the intelligence for network traffic analysis, as well as the intelligence for network detection and response. So we have a very robust portfolio of products to help secure the private cloud. Now, that being said, this is not an all or nothing proposition. You get to pick and choose the pieces that solve the business problems that you are trying to solve. Now, most customers begin with the distributed firewall, and we can absolutely suggest a prescriptive iterative plan to buy down risk, but ultimately it is up to the customer to figure out the order in which they would like to take advantage of these. When you buy vDefend, you get all of these. You use them as you need in order to solve the specific business problems or the use cases that are relevant to each one. So let's start with the distributed firewall. The distributed firewall, which is maybe the most powerful, but certainly the most common security tool out of the bunch that customers begin with, is a layer 2 through layer 7 stateful firewall. Layer 2 through layer 7 stateful firewall that runs at the VNIC of every workload running in the hypervisor. So virtual machines, and also works for containers. Now, if you think about this, this is a very unique architecture. The historical model of quote unquote firewalling is exactly what you see in the bottom left-hand corner, this physical device, and we have to force traffic over this device in order to be able to do inspection. Well, the distributed firewall, the layer 2 through layer 7 stateful distributed firewall, does not have any type of requirement from a networking perspective. We are disassociating the relationship between IP and security. In my image here, these virtual machines could all be on the same host and the same IP subnet, and we are still going to get stateful firewall inspection. Other side of the coin, these could be VMs on different hosts, on different networks, and we are still going to get stateful firewall inspection. So we are not requiring that the physical network or the software-defined networking have any specific configuration. That's the disassociation of IP to security. IP is no longer the boundary for security. Now, if you're thinking about this in the context of traditional firewalls, you might be sitting there wondering, wow, a firewall at every single VNIC of every workload? Does that mean if I have 10,000 workloads that I have 10,000 firewalls? That's exactly what it means. If I have 150,000 workloads, I have 150,000 firewalls. That's exactly what it means. And it's okay to think that way. But what you need to understand is that in addition to the architecture being extremely unique, running in the hypervisor, is that we built a management plane running in NSX Manager that allows you to manage these policies unlike traditional physical firewalls that require IP-based. So we've done a phenomenal job at reinventing the management plane to give a scalable, easy, and effective way of managing all of these firewalls that exist in the environment. So distributed firewall runs in the hypervisor across the entire environment, scaling linearly across the entire environment. Now, the gateway firewall would be our instantiation of an appliance-based firewall. So it can be a physical system, it could be a virtual machine. But the idea being that we can protect non-virtualized workloads. So imagine a VLAN out here, and that VLAN has some physical servers that you would like to protect. Well, the gateway firewall is a great solution for this. Architecturally, is it any different than a Palo or a Checkpoint or a Fortinet? No, it's not. What the advantage is when using the gateway firewall is the manageability. You get a single management plane now to control flows across your entire private cloud environment. In other words, the demarcation point for security can be drawn here. And your existing firewall vendor will handle things in and out of the data center, while the VMware vDefend handles everything inside the data center. So gateway firewall, virtual appliance, or physical machine. Now, the bare metal agents another solution that allows us to close the security gap in our environment. And what I mean by that is what happens if you're not 100% virtualized. So again, let's say that there's a VLAN, and that VLAN has some physical systems on it. The bare metal agent can be installed inside those systems. Now, this is for a limited set of Linux operating systems right now. But again, is there any difference architecturally from other third-party type agents? No. The advantage is in the manageability. It's in the single management plane to control flows across both the virtualized and the non-virtualized workloads that you have in the environment. Now, IDS IPS, like the distributed firewall, so let me put the distributed firewall in here. IDS IPS is in hypervisor intrusion detection, intrusion prevention. So if we are passing this traffic through the hypervisor to get into or out of a virtual machine, not only are we now able to inspect that traffic layer 2 through layer 7, but we can also look at that traffic to determine if the network fingerprint of that traffic matches a known bad pattern of traffic. Is this something malicious? Is this a flow for which there is a signature because it is a known bad flow? And we can do this in real time in the hypervisor. We are not sending this to some service virtual machine. We are not sending it to some end of row. This is policy driven in real time, looking at the traffic flow. So again, very unique in the architecture, but of course we own the hypervisor. So any opportunity we have to extend the functionality of the hypervisor and allow customers to take advantage of the distributed architecture that they've already invested in for more powerful features, we're certainly going to continue to do that. Now, the IDS IPS is where we can certainly have a strong tie-in to what we're hearing these days as frontier AI models. So if you are not familiar with frontier AI models, Anthropic released a model named Mythos. It is a frontier AI model. And these models are very, very good at discovering vulnerabilities in workloads, right? So identifying bad code where there's a vulnerability, and then identifying whether or not that bad code actually translates into something that could be exploited. So what's happening now in the landscape of cybersecurity is that if we look at how vulnerabilities were discovered in the past, right? Step one was to discover a vulnerability. So something like a zero-day attack. Step two was for the vendor to actually create a patch. So let me put create the patch. And then three, which was often the longest piece, was to install the patch. We all know patching is not people's favorite thing to do. So oftentimes customers just hold off as long as they can to patch. Well, the problem with this now is the following. The frontier AI models are shrinking phase one drastically. And you can visit a website called zerodayclock.com. I believe it's run by the CISO of a financial institution. And it shows you that the trajectory we are headed towards is that zero-day vulnerabilities will be found in a matter of hours or minutes as opposed to years. Now, phase two is still up to the vendor to be able to create the patch. But realistically, if you're a customer, it doesn't matter how fast it's discovered or how fast the patch is created. What matters the most is how quickly can I respond to this patch? Can I match the velocity of identification and creation with the installation of the patch? Because if I can't, I'm actually at a tremendous disadvantage here. I would rather the vulnerability have not been found for several years. But now that these things are being found so quickly and patches being put out so quickly, I have to be able to match that velocity. So the question becomes, how do I shrink that third phase? And so one of the things that we have as part of VMware vDefend is something called virtual patching. And this is leveraging our IDS IPS engine. Virtual patching is not new. This is not a response on the part of VMware to these frontier AI models. This is not something that we thought, oh, we need to be able to respond to these frontier AI models in a way that allows customers to patch quickly. This has actually been in the product for a while. So kudos to the product managers who thought about this, and they're now getting a very, very high profile solution that maps to what customers really need today to protect workloads in a response to these frontier AI models. So here's what happens. Phase one, vulnerability is identified. Phase two, a patch is created. Phase three, though, the installation of the patch. So let's say that we have a particular virtual machine for which one of these frontier AI models has identified that there's a vulnerability. So I go to the application owner and I say, hey, application owner, there's a patch for this. I need you to deploy this patch. Well, the application owner is going to come back to me, or the developer, whoever it is going to come back to me and say, okay, yeah, I understand. I need time to patch this. And you say, okay, great. How long do you need to patch it? And they say, I need 6 months. Well, that doesn't really work out for me. As somebody who's very security focused, I can't sleep well at night with the idea that for the next 6 months, I have a system with a globally known vulnerability that's been identified by a frontier AI model, and for which there is actually a patch that can be put out. Now, if you remember, because we have the ability to look at the network traffic coming in, what we can do with virtual patching is we can apply the fix in the hypervisor level by understanding the network fingerprint and blocking it at the hypervisor level. So we are not installing anything inside the VM. This is not patching the workload. This is not touching the operating system. This is us understanding the architecture of this exploit, this network fingerprint of the exploit, and then leveraging the hypervisor to recognize that fingerprint and disallow the traffic from being passed into the virtual machine. This is extremely clever. This is extremely powerful, because now, if we look at phase three with virtual patching, we can operate at the same velocity as these others. This is all policy driven. So once the patch is out, it could be minutes for me to deploy a policy to protect a workload where this vulnerability exists. We are handing security teams, virtualization engineers, a tool that allows them to mitigate against things without the need to impact the actual operating system or application. This is extremely powerful. And this right now is a very hot topic among our customers as a response to, again, the velocity at which AI is not only finding these vulnerabilities, but being able to exploit these vulnerabilities. Now, malware prevention is also in hypervisor. Another unique opportunity for us was to say, well, if we know that something is known malware, if we know there's a particular embedded PowerShell code that does bad things, if we know that there's certain files that are malicious, why don't we leverage the hypervisor to be able to prevent them from being passed into a virtual machine? Now, in your virtual machine, likely you're running some EDR in there, and that's fine. We're not trying to tell you not to run an EDR. What we're trying to do is build defense in depth. What we're trying to do is leverage the hypervisor to stop something sooner rather than later. So instead of passing it into the VM, and then maybe the EDR finds it, or maybe it's a little too late, but the EDR says, oh, I see this bad thing has happened. Now I need to quarantine this VM. Maybe the EDR stops it from happening, but maybe it doesn't, and now we have to quarantine. But ultimately, the same CPU and memory that would have been used inside the VM to execute this file with known bad code is the same CPU and memory that's in the hypervisor. So all we haven't done anything to change resource utilization. All we've done is change where the enforcement point happens from a security perspective. So if you're catching the drift here now, I think you're starting to understand that the hypervisor is actually becoming a very, very important part of security. So not only do we need to secure the hypervisor, but the hypervisor can be used to secure the workloads. So there's this opportunity now for the virtualization infrastructure team to have not only a seat at the table when it comes to security, but in the enterprises that have very heavily invested in virtualization, right? 80, 85, 90, 95%. That seat at the table is a very big one because it means that there are tools purpose-built to protect those workloads that do not rely on any other aspect of the infrastructure. So everything I've talked about so far, these protective measures, can be implemented without making a single change to the physical network, with the exception of maybe the gateway firewall. But these other things, the in-hypervisor things, I don't have to go get the networking team to do any specific configuration. I don't have to go get the firewall team to do anything specific. And this is really part of having a security mindset. The idea that all of the different silos in the enterprise have to play some role in security. The physical network team should be allowed to implement security using whatever tools are built into the fabric that they use. The firewall team does what they do. The EDR team, the SecOps team, the storage team has some role. What we are doing is bringing the virtualization team into that mix with what could be a very big role. There should be no interreliance among them. Not that they shouldn't communicate, but there shouldn't be any reliance on one team in order to implement some security procedure, because then there's too much politicking that goes on. So distributed firewall, IDS, IPS, malware, these are things that can be done that do not require a change to the existing infrastructure. All right, let's talk about SSP. SSP is the Security Services Platform. This is part of vDefend. This is a container-based platform that can be deployed in either your management domain or workload domain. But SSP is really the analytics and intelligence engine behind VMware vDefend. And let's explore what that means. So SSP is collecting flow data from the hosts. And I don't mean just sampling. There's no IP fix, there's no spanning and tapping and all this kind of stuff. It's just inherently part of our solution that we are going to collect flow data. So all of this flow data is sitting inside of SSP. And then there's nothing really magical about flow data. There's lots of tools that provide flow data. What's great about SSP is what we do with that data and the opportunities we provide with that data. Starting off with a feature called the security journey. The security journey is a prescriptive plan that allows customers to take a step-by-step approach to protecting their private cloud. And this is built into the product. You can actually move through these steps at your own pace. Step one is a security assessment. In other words, we're going to look at the flows that have been collected, and we're going to generate a document for you. We're going to show you how bad or how good things are in your environment. Now, this is not the MITRE ATT&CK framework or the NIST framework or any third-party framework. This is us as VMware by Broadcom, understanding what our capabilities are to help you mitigate against common threats, and then reverse engineering what, if any, of those things have you done. So you might get your security assessment back and you have a score of a 7, whatever it might be. Step 2 in the security journey is to protect the infrastructure level protocols and services. So if you think about some of the high value targets for attackers, not necessarily the endpoints, but the way that attackers move, and in some cases endpoints, certainly attackers are looking to take advantage of things like remote desktop protocol, SSH, server message block, SMB, DNS, Active Directory, NTP, all of these core protocols and services that we have. So as part of the security journey, SSP can help you identify those network protocols and services and build the respective tags and groups and policies that you need to protect them. Now, let's say you go through phase 2, step 2, stage 2, and now you want to see what you look like. You can run the security assessment again. Now your score goes from a 7 to a 22. Okay, cool. There's progress. We're buying down risk. We're making moves. Stage 3 is to build zones, production, test dev, DMZ, all of these different areas or zones that organizations deploy and need to control traffic flows between. SSP can help you build the policies to establish these zones in your environment. We are effectively beginning the process of shrinking the blast radius for a threat actor. If somebody gets into the DMZ due to some exploit, by having zones, we limit their capabilities within the DMZ. They cannot move from DMZ to test dev or DMZ to production, etc. So a very, very important part of controlling lateral movement is the establishing of zones. And whether this is done through different clusters or whether you have your different zones running on shared clusters, it doesn't matter. That's just architecture. But our implementation using tags and groups and policies is still going to be the most powerful way to establish zones. So now you go through the zones process. You want to see how you do? You go back to the security assessment. You run it again. Oh, look at that. We went from a 22 to a 58. I'm just throwing arbitrary numbers out there, but you get the gist. We're making progress. We're buying down risk. We're shrinking the blast radius. And as we do these things, we are therefore improving our overall security posture, and we're getting better. Now, stage 4 is when we finally get to the applications. And I'm not jumping straight to microseg because we can do macro segmentation. In other words, app A can't talk to app B. App A can't talk to app C. App B can't talk to app D. So macro seg, or application ring fencing, as some people call it. Or we go all the way to that nirvana of lateral movement control to microsegmentation. So where macro segmentation would be the inter-application communication, microseg is the intra-application communication. Microseg is web talks to app, and app talks to DB only over these specific ports and protocols. That's the micromanaging of the way application can communicate among its components. And SSP, it helps you do all of this because it has that flow data. Now, we can add some context to SSP, and this is really cool. But let's say that you have a change management database. And in that change management database, you already have information about your assets, your virtual machines. And you've already started to build a tagging taxonomy that identifies what these assets do and where these assets live. you can export that to a CSV file. And then probably with a little bit of massaging into the right format, you can then import that CSV into SSP. At which point now, not only do we have flow data, but we're now being provided this rich contextual information about the assets in the environment. SSP then has the opportunity to help you build tags and groups and policies with this additional context applied to it. Now, if you don't have a change management database, no big deal. We provide you with a template. You could download the template. You could build it yourself. Pick your favorite coding model. Tell it to write you a script to pull some information from vCenter, and then have at it. As you build your own CSV file, building out your own tagging taxonomy, you can then bring that into SSP, and SSP will convert that CSV file into a vDefend tagging and grouping and policy scenario. Now, part of SSP is also something called security intelligence. Security intelligence is rule recommendations. So outside of this context of security journey, outside of the 1, 2, 3, 4 steps, you can leverage security intelligence to be able to point it to an application and say, provide me with all of the flows, provide me with rule recommendations. So it's similar in nature in that what we're doing is looking at flow data and taking all the guesswork out of how you would build policies to protect that specific asset in your organization. Moving along, network traffic analysis, NTA. Now, with all of this data that we have in SSP, it would make sense to apply some learning to this data. So in our diagram here, let's say that we've got a particular set of flows that we've been capturing. And now all of a sudden, there's the capture of a flow between two systems that have never talked to each other before. Network traffic analysis understands this anomaly and has the ability to identify this anomaly to us. It doesn't know if it's good or bad just because it's an anomaly, but it has the ability to tell us that this anomaly has occurred. If we want to know if it's good or bad, that's where we need the understanding of malware detection or IDS, IPS to understand that this particular communication has had a negative impact or is not something that we really like. But NTA is just about understanding those flows. And then finally, NDR. And this is where things get super interesting. I love this part of the story here. So NDR is network detection and response. Now, if you think about the anatomy of an attack, and so we're gonna walk through this here. Let's say that an attacker, through social engineering or phishing or whatever it might be, gets into the environment. Let me get rid of some of these things here. Okay. So the attacker gets into the environment and lands right here on this first VM. So then they install some command and control software and it reaches back out to the attacker. Attackers thinks, all right, well, there's nothing really here of value. So then the attacker moves laterally, let's say using remote desktop protocol. And then they install their command and control software and then they reach back out and, okay, well, there's nothing really good here either. So what do? Then they move again. They install their command and control software. They go out and now it's jackpot. Found what I was looking for. So what do? They encrypt. And now we have a ransomware event. Well, all of those different movements, we have that flow data inside of SSP. What NDR does, NDR is equal to the sum of the network traffic analysis intelligence plus the IDS IPS intelligence plus the malware prevention intelligence. But this is a situation where 1 + 1 + 1 does not equal 3. 1 plus 1 plus 1 here. The sum is, the total is greater than the sum of the parts here. Because what NDR does now is it says, well, wait a minute, I see all of these flows and I see this bad command and control software. These are not anomalies. This is actually an attack campaign. And so NDR boxes all these flows up into a campaign. Now we have rich contextual data about exactly what happened in the environment. We know that they went from virtual machine 1 to virtual machine 5, and from virtual machine 5 to virtual machine 8. We know that it was this specific command and control software. We know what they did to encrypt. Now, what's the value in this data? Well, anytime we deal with cybersecurity, there are 3 specific phases that we have to look at. There's the protect phase. What are we doing proactively to mitigate? There's the detect phase. What are we doing to identify when something bad has happened? Where is our visibility into the environment? And then the last one is you got to be able to recover. Now, we hope you never have to recover. And it turns out that the more time you spend protecting, the less you should have to detect and the lower the chances that you have to recover. But ultimately, if you do have to recover, the amount of time it takes you to recover is going to be directly correlated to how good your protect and detect were. So in the case of NDR, if NDR is giving us this attack campaign, we would know exactly what got hit and when. And that information we can now take to our integrated recovery or isolated recovery environment, And in that IRE, where we have immutable backups, snapshots, we then know exactly what we need to restore. So I need virtual machine 1, and it was 3:20 p.m. on the 16th. And I need virtual machine 5, and it was at 4:45 on the 17th. And I need virtual machine 8, and it was 3:20 p.m. on the 18th, right? I know exactly what got hit and when. Now, you'll know for number 8, you'll be able to find that one pretty easily because the application stops working. Somebody calls in and says, hey, I can't do this. Through a little bit of troubleshooting, you get to a console, you open up the console, and there's a nice message there that says, hey, you owe me 4 million in Bitcoin. Here's my wallet. You'll know that was compromised. But if that's the only thing you know, even if you recover that, so in our example here, let's recover that. And that means I pull out the eraser. Even if you recover that, the attacker is still sitting in the environment on virtual machines 1 and 5. In order to fully recover from a cyber incident, you have to have rich contextual information about the attack chain. You have to know every hop along the way that they took. That's the only way to reduce the mean time to recover, at least confidently reduce the mean time to recover. If you don't know the what and the when, and you go into your integrated recovery environment, so here I am in my IRE, what is my only other option? I can restore the database that was encrypted, but if I don't know the other components of the attack chain, do I just start at the first virtual machine? Look at it in my production environment. Is this compromised? Oh, no, that one looks good. Okay, let's go to VM2. Oh, no, that one looks good. Let's go to VM3. Oh, no, that one looks good. Working our way down until what we find that one has been compromised. And now what? Now we got to figure out when it was compromised. So we go to the IRE now. We say, okay, I want to look at virtual machine 5. Let's take this previous snapshot. Oh, no, that's still bad. Command and control software is still there. Let's go back another snapshot. Oh, no, it's still there. Let's go back another snapshot. Okay, there we go. Now it's clean. that's going to take you months and months to recover from. Because every one of those snapshots is not a matter of seconds or minutes. It's hours and hours of recovery after recovery after recovery, trying to figure out if something was compromised and if it was when. So NDR is extremely important. The data that we put together for you is extremely important. And whether you consume that data through our own interface or whether you export that data to your own SIEM or your own SOAR, the importance is having that data. The importance is turning on NDR, turning on NTA, turning on, at least in detect mode, IDS, IPS, and malware, because that's the only way that I'm going to get really strong visibility into what's happening in my environment. And the beauty of it, you get all of this with VMware vDefend. Distributed firewall, gateway firewall, bare metal agents, IDS, IPS, malware, SSP, security journey, NTA, NDR, all part of vDefend. All at your fingertips at whatever cadence, at whatever velocity you want to implement these things, and all without making a single change to the existing fabric. No changes to the network. No changes to your vSphere environment. I'm assuming you're running VDSs, but it's a very powerful tool. It integrates very easily into your current operational model. The learning curve is very short in doing these things, especially the distributed firewall. IDS IPS is not something you would turn on carte blanche for everything. It's policy driven for specific workloads. Same thing with malware. And then, of course, if you want help, if you want support, SSP was engineered to be able to help customers move rapidly. I've seen customers go from 0 virtual machines protected to over 6,000 on day one. One day is all it takes to be able to protect. So thank you for joining. I hope that you enjoyed this presentation on VMware vDefend. Feel free to follow up with your account team. I'm Chris McCain. Have a great day.